Thank you very much, Zilla. So, as Zilla mentioned, my name is Edward Miller, and over the past 5 or so years, I've been lucky enough to be working in the field of virtual reality across marketing, healthcare, and journalism. But I thought today I'd like to talk to you about Pokemon Go and augmented reality. And before we do, I'd just like to kind of kickstart your memories and start off with a few little facts. So, 200 million is the amount in dollars that Pokemon Go generated in the first month of operating. 23 billion is the amount in dollars that the market cap of Nintendo went up by in the days following Pokemon Go's release. 25 million is the amount of people that were active users on Pokemon Go in the US alone, okay? And this is just a selection of the applications that have lower daily user engagement than the average Pokemon Go user. And that includes Tinder, so you know where people's priorities are kept. Now, you'll hear a lot of discussion about whether Pokemon Go is or is not true augmented reality, but regardless of that question, I thought it would be quite fun to have a little thought experiment and see what might we want to expect in the next version of Pokemon Go, in the next revolution of Pokemon Go 2.0. And we start off with the headset. So the current manifestation of Pokemon is that we hold out our mobile phone and we can walk around parks and hold it up. And we've got this kind of abstract window into the virtual world. But it doesn't really live up to our expectations of having a completely blended environment of physical with digital. So we need to start off and move towards a head-mounted display. And what properties might this head-mounted display have? Well, first of all, we need to make sure it is portable, okay? We need to make sure we can take this out of our houses. It needs to be decoupled from big, heavy computers, and we can actually take this around in the environment. And believe it or not, we've actually seen one version of a portable augmented reality headset in the past. I'd just like to show you a video of several years ago now. So believe it or not, this was the first portable augmented reality headset device.
And what I'm looking at. So when we do this, we can then augment the real world, which I'm in now, with the virtual world. So this Pac-Man world, I'm seeing it as part of the real world. I can see cookies in front of me, and I'm walking through them as if I'm the human Pac-Man.
So that's portable augmented reality, but it doesn't really, again, live up to what we really expect from this new medium. We need to be able to wear this, take it out, and feel comfortable wearing that. And that brings us on to the next question. We need to make sure that we can actually feel comfortable wearing this because it feels good. We're putting this technology on our face. It needs to be something that we feel comfortable with. We all remember what happened with Google Glass, with the term glass holes that they grew to have. So we need something that represents us. And actually, we've started to see a little bit of an indication of one company that might be creating a headset like this in the form of this. It was by a company called Snapchat. This is Snapchat Spectacles. Now, admittedly, this isn't an augmented reality headset. This is merely a camera that is built into a pair of glasses. But they've done one thing that none of the other companies have achieved yet. They've managed to get their glasses, they managed to get their head-mounted display or head-mounted camera to look like you could pick it up for about $5 from a local store. And that is to their testament, okay? Because you're not going to have a question of them and us. It already fits with youngsters' traditional mindset, okay? So we really need to have that. We also need to have object recognition. True object recognition, be able to look at any item and for the headset to know exactly what you're looking at and to be able to deal with that in a corresponding fashion. So traditionally, augmented reality devices have used these things, a little bit like QR codes, where the device will look for these QR codes, read the information that's set into that QR code, and can then pop up something in front of that. So again, we can do some interesting things with these already. I'll show you one video from that. And I'm not using this to ridicule this guy, I promise. But again, it doesn't quite live up to our expectations of what AR could be.
Go. I'm Brian, and today I will become Optimus Prime.
that is brilliant in its own right, but it doesn't live up to our expectations. What we want is a system where we can overlay digital objects, rich digital objects, and experiences into the physical world, to be able to understand a space around. And that's what my new company is working on right now, which we'll get into a little bit at the end. We also need occlusion handling. We even need to be able to see, right, if this is a virtual object, it needs to block out the real world behind it. It needs to have a fundamental understanding of the shape of things around. And I'm going to show you a video now from the company which many of you will already know, which is called Magic Leap. Incredibly interesting company. And actually, I'm going to point out when I want this device to be paused, so I can just point out something that's incredibly important. So if we pause this video now, a little bit too late. If we can back up a little bit on the timeline. So this is very clever. Okay. You are seeing a digital item, a digital robot that's overlaid onto the physical world behind a table leg. That's very hard to do, okay? That's very hard to do. And Magic Leap has technology that allows them to do this. And it's a bit of a problem at the moment. You know, in order to do that, you need to know exactly where the device is in space. And it's a chicken and egg problem at the moment, because how do you know exactly where you are in space if you don't have a map of that space already? How can you build a map of that space if you don't know exactly where the device is? And there's actually a solution to this in robotics. It's called SLAM, or Simultaneous Localization and Mapping. So with the most modern augmented reality headsets like the HoloLens, they actually have these SLAM capabilities built in. They have a few cameras built around the side, and they spit out a UV pattern, a pattern of light with UV of a specific pattern, and then a receiver. So because they know the pattern of this light, when they have that pattern back, they know that any changes in pattern is a result of shape in the space. So they can walk around an environment building up this map of the space whilst knowing exactly where it is in that environment. And it's okay. But at the moment, it's a little bit like, I don't know if any of you are aware of the computer game Command & Conquer, but any of you that don't, you start off in an environment that's in completely black. You have no map at all. And as you move your characters around the map, you start to build up an idea of what this environment actually looks like. And at the moment, with these augmented reality headsets, it's a little bit like this. Everyone is in a silo. They're creating their own individual map that they can look into, but there's no sharing involved. What we really want to have is collaboration, a collaboration of building maps together, so that if you go to an environment that you haven't been to before, you can make a call to a server and find out the map of that space. So you can now place items anywhere in the world, and anywhere, even if you haven't been there before, you can recall to that shared map. And once you have such a very large map, you've then got another little problem. If you've got such a large map, how can you figure out exactly where you are, okay? Now, this is a hard problem. There's a website called GeoGuessr, which you can go from, I think it's like geoguessr.com. You can go on there, and it will pick out any random Street View image, and you can test yourself and figure out if you can decide where it was taken. And actually, traditionally, humans are pretty bad at this. But last year, in fact, earlier this year, Google came out with something called Planet. And they took a very large data set of images, pushed it into something called a neural network, which, for all intents and purposes, you can think about as AI. And they trained this AI system for 3 months. So you could then give it any image, and it could predict with about 10% certainty the closest city to this image was taken. That's with no GPS information at all, just the image alone. That's phenomenal, okay? How can we make the system better? Well, we need more data, because once we have more data, more imagery, we can do more interesting things. So this is another video I'd like to show, and what you're looking at right now is not a video in the traditional sense. So this is a photorealistic model. It's similar to how a computer game character might be built up, but it's using photographic textures, okay? So for all intents and purposes, this can get as close to reality as you'd want. And I'll skip forward. So the way that model was captured is a model stood into a room when they're surrounded by about 150 different cameras that all captured different angles of this model at the same time. You can then build up all of those imagery and build a 3D model from that content. Now, rather than cameras looking in to a subject, you can also do it the other way around. You can also look out and build a model of an environment, okay? And I thought it'd be a little interesting project to explore, what are the minimum hardware requirements to actually build a model of the environment? We know that Google's been doing this for a while, but actually, we can take a Samsung Gear 360 camera, like it's down there, that you can pick up for about £230, okay? And this was a project I did when I was with a fantastic VR company called Rewind. We actually walked down a street holding up this regular £250 camera, capturing video. We can then extract feature points from that video and build up and triangulate where these feature points were in space. We build up this kind of 3D map of the environment. We turn that 3D map into a denser 3D map. We turn that denser 3D map into a mesh, and we then reproject the textures back onto the mesh. Now, I'm not showing you this to show the visual quality of this mesh. I'm showing you this to show this is all the information we need to be able to train a system to know exactly where you are if you hold up your mobile phone anywhere inside that street, okay? You can be in the corner of that street where we haven't mapped out exactly, but you hold up your mobile phone, we know exactly where you are, and because we know exactly where you are, we can now put digital objects exactly where you want them, okay? You can't do this with GPS. GPS isn't accurate enough. And how do we improve this? Well, we use more data. We can actually build up a model of the city of Dubrovnik using just imagery that tourists have captured on their holidays, okay? And again, using this system, we can localize any device anywhere on any of the streets in the city of Dubrovnik and be able to overlay an augmented reality experience, augmented reality content, digital content onto the physical world using this map, okay? This is what we're doing with my new company, Scape. So we're working on city-scale augmented reality. Okay, and we'll be releasing some early beta products at the moment. And if you are interested in these things, please get in touch with me or go to scapear.com and sign up to be an early beta user. I'd love to talk with you more, so please come and find me later on. But that's all from me, so thank you very much.